start to today. I'm kind of cheerful mood. So let's jump right into the integral test. This is basically a very, very condensed description of what the integral test says. It says, see if you've got a series, sigma n equals 1 to infinity of fn, you know, like n over n squared plus 1, whatever. It behaves the same way as this integral. So what the integral test does is, it says, okay, do you want to find out if this converges or not? And that's the only thing that you'll get. You won't be able to do, oh, and its sum is 42, right? You won't get that second part. All the integral test does is it allows you to say this converges or this diverges. Converges means it adds up to some number. We don't necessarily know exactly what that value is, but we know it exists. And diverges means it's infinite. Forget about it, guys. So here's my first example. I want to check this guy out. Then I am going to check the equivalent integral, which is that guy. And at this point, Calc 2 takes over. You can forget about why we're doing it and just focus on getting that integral. If this ends up being 3, 4, right, any finite number, right, zeros, right, 22, anything like that, you're cool, right? It means that this series converges and that's the question over. And if this ends up being infinite or undefined in some way, then the answer is this guy diverges, and that's it. So the first thing we do is pretty standard, is that you replace the infinity with t and make it the limit as t tends to infinity. And then you have to get all the old cobwebs out your brain. Because I need to integrate x over x squared plus 4. And I might do it with the power rule. I might do integration by parts. I might do u sub. I might do trig subs, right, x subs. I might do, excuse me, that I'm just good at remembering certain integrals, you know, like I know what the integral of 1 over 1 plus x squared is and so on. What technique will I use to integrate x over x squared plus 4? What method
U sub?
should I use? Correct. And the minute you say u sub, you then should say who the u in the u sub should be. In this question, what will the u sub be?
The x squared plus 4?
Correct. If you remember, at least if you got me, the way I teach it is, do you remember that there's sort of rules that work most of the time? There are always exceptions to them. And isn't one of the rules, if it's a fraction, the guy in the bottom is your u sub? Right, that's one of the kind of rules that we use to identify who the u sub is. Now, once you've done the u sub, you then go through a little process that looks something like this. You differentiate with respect to x, and you do the guy I call the crossover, and then you isolate the dx. So now if you got someone else, you may not quite do it quite this way, but the bottom line is it's going to end up being the same thing, right? So it's not like it's a difference in answer, it's just a difference maybe in the method. I know everybody who's had me will recognize this because this is the way I've taught. But people who didn't get me for Calc 2, does that look vaguely familiar? Right, so you know the gist of it. You may have a small difference, but nothing major. So I'm going to go over here now, and it's going to be the limit as t tends to infinity, the integral, which I'll kind of put that in technically, I shouldn't. That's an x, that's a u, and the dx is 1 over 2x du. And that's now going to be the limit as t tends to infinity. The x's cancel and you've got a 2. I would call that 1/2 of 1 over u. I think that's an easier way to write it, rather than calling it 1 over 2u that tends to cause trouble. Which now means that I can integrate it with respect to u, and it's 1/2 the natural log of u, right? I'll just put a little bracket around it. And then I'll convert it back to t's. When I convert it back to t's, or x squares, I should say, and then x equals 1 to t, that's what I meant when I said the t's. It's the half log u becomes a half log of this, evaluated from 1 to t. Then you plug in the two different limits of x. And on one side you get half the natural log of t squared plus 1. And the other side you get minus a half of essentially the log of 5. Right, 1 squared plus 4 is 5, half of that.
Isn't that t squared
Now at
plus
this point
4?
here,
Isn't
say
that
again?
t squared plus 4?
Oh, yes, thank you. T squared plus 4. Now, at this point here, you're trying to find out the limit as t tends to infinity. This particular case is just going to be brute force, right? I'm just going to make t infinite and the answer's coming out pretty easily. Sometimes you have to, depends on what you get, but, sometimes you might have to do L'Hopital's rule, or you might have to do, divide the top and bottom by t squared or something. But in this case, would you agree that the answer is a half log infinity, take away that, which is basically infinity, isn't it? Because isn't the log of infinity infinity, and half of infinity is still infinity? And taking away a little number from infinity is not going to damage it in any way. That means that this diverges, right? We say that the integral diverges. It also means that this series then does the same thing. It diverges. So if you took this particular series and you added up all the terms starting with n equals 1 and just keep going till you get tired, that entire series would end up being infinitely large, right? It would just go on forever and get bigger and bigger. Are we comfortable about the process? So that was an example of using the integral test. That actually is not unlike question 1 from the homework. I'm going to see if I can get one that uses a different technique. How about this one? Sigma n equals 1 to infinity. Excuse me. That guy. Well, the equivalent is that guy, right? So we're going to find out what that integral looks like. If it converges to a number, then the series converges. If it diverges to infinity, then the series diverges. This is not a u sub. If it had been that integral, it would have been a u sub. And if it had been that integral, not only would it have been a u sub, but the u sub would have probably been negative x squared or x squared if you prefer. But it is not that. It's minus x. So what technique, integration technique, do you use to integrate this guy?
Integration by parts.
Correct. And that's kind of where we are right now, integration by parts. Okay. Now, in integration by parts, don't you have to pick an f and you have to pick a g? At least if you do it from my class. Some of you, the others came from a UDV world, and that's fine and it works, but I'm going to do the f of x, g of x. In this case here, won't the f of x be him and the g be him? Agreed? And the reason I'm choosing that is because isn't the derivative of x simpler, and therefore the whole integral will eventually become simpler. So that was the choice. So I'm going to need more room, so I'm going to go over here. It's going to be the limit as t tends to infinity. I'll forget about the limits now, because technically the minute you start moving things around, it gets a bit messy. I guess I can put them in. just for arguments. No, I don't. Change my mind again. It's going to be f big G, take away the integral of f dashed big G dx. And that's what integration by parts formula looks like if you're doing the FG technique. Now, what I'm going to do here is just go through the process and totally ignore the 1 to t part until we get to the end, right? Until we've integrated everything. And then I'll do a vertical line from x equals 1 to x equals t. If I start putting it in places and not other places, it just doesn't look right in my brain. So you've got this guy. Now, if you integrate, right, if you find the antiderivative of this guy, I agree he is e to the negative x, but he's not just e to the negative x. Isn't there something else going on here? So what's missing? Negative. If you did e to the 5x and you found its integral, its antiderivative, you would get e to the 5x, but wouldn't you also get a fifth? And if it was even weirder looking, that one, you would get e to the negative 5x, and then you'd get a negative 1/5. Are you all comfortable about the linear shortcut, which is essentially what's happening here? So we are going to get negative e to the negative x. Take away the integral. Well, if you differentiate this, you get 1, and the other guy looks like this. And all I'm doing in this next line is trying to make things look a little bit prettier. That's the first guy. The negative of a negative cancels out, and all you're left with is this fella. And now you can do the limit as t tends to infinity. That guy stays put. And this fella, is negative e to the negative x. And at this point, I'm going to put the x equals 1 and x equals t in. That I've kind of been avoiding because it gets messy if you try and figure out where it goes. So if you're doing this question, I suggest that you just forget about the limits of integration until the whole thing's integrated as it is here. And then you can put them in. So let's see what we get here. We get negative x, negative t, e to the negative t, take away e to the negative t, subtract negative 1 e to the negative 1, so that's this guy, and take away e to the negative 1. So that's going to be the limit as t tends to infinity of negative t e to the negative t, negative e to the negative t, plus 2 e's to negative 1. We're almost finished, but there might be a problem in figuring out what the heck this looks like when t goes infinite. Because if I just do a brute force, this term here especially is going to be very hard to predict. Because won't this term here be negative infinity times e to the power of negative infinity? Can you see that that's going to be a bit awkward? You know, is that 0? Is that infinite? Is it 22? I mean, it's not obvious what that is. So I'm going to do that separately. So the limit is t tends to infinity of this guy. And the first thing I'm going to do might not seem obvious, but it is going to be helpful. Isn't that the same thing as this? Agreed? Now, the reason I want to write it like this is for this rather awkward situation, brute force isn't going to work. L'Hopital is. And if I'm going to use L'Hopital, don't I need a fraction to use L'Hopital on? So I'm now going to do L'Hopital, and he says you differentiate the top and the bottom, which means I can now do brute force. isn't e to the power infinity infinity? And isn't negative 1 over infinity 0? So this piece, just this piece here, is 0. Okay, let's look at this fella separately now. If I rewrite this guy, I don't need L'Hopital. I'm just rewriting it this way because if you write it like this, isn't it a little bit more obvious what the brute force answer is going to be? Because 1 over infinity is 0, so you get negative 1 over infinity, you get another 0. And this guy is basically 2 over e. So our integral converges. And that means that this fella here also converges. But, and let me emphasize that, it doesn't mean that this adds up to 2 over e. You know, like when we did the geometric series, there was a formula that told you what a converging series would look like, right? The S equals a over 1 minus r. That 2 over e is only what the integral converges to. This fella up here will converge to something probably less than that number. And there is no formula for you to find out what that is. And you can look at the theory and it'll tell you how you can get boundaries and estimates of the answer. But here's the easiest answer. I know that that converges to some number. I'd like to estimate what that number is. Without doing too many clever math, what would be the simplest way to get an estimate for what that series adds up to?
Integrate it.
Huh? Integration is how we would test if it converges. But my question isn't, does it converge? We've already done that. I just want to know, what does this add up to, or at least an estimate of what it adds up to. I know it's a convergent, right? So I know it does add up to something. You know, it's a unique number that it adds up to. But how could I estimate what that number might be?
Draw a graph.
Couldn't we just maybe add 20 of the numbers together? Like just add the first 10, first 20.
Would it be 0?
So for instance, say again?
Would it be 0?
No.
Oh, you
won't be
never
0.
mind.
What it will be, this is not perfect, but if you add these guys up, so what would that be? 1 over e plus 2 over e squared plus 3 over e cubed, and finish at what? 20 over e to the 20. Can you imagine doing that calculation? That would be an estimate for what that adds up to. And one of the properties of series that converges, most of the value is in the first 5 or 10 numbers, right? So if you add up the first 5, 10, 15, 20 numbers, what that adds up to is pretty darn close to what the entire series adds up to. Because for this to converge, don't all the other numbers after, say, the first 20, don't they have to be tiny and getting even tinier? So that if you add them up, they don't come to much. You know, that's why it converges. So that's how you would do an estimate. You would just choose a number like 20. If you wanted a more accurate answer, couldn't you just add up the first 200 or the first 2 million, whatever you felt like? Yeah, get a computer to do it. Nobody wants to do that by hand. Are we good? Right, now, I'm going to go over and we're going to have a look at some of the homework questions, and I'm going to talk through a few of them. And we'll see how it goes from there. And boom, boom. Right, maybe make this a little bit bigger. There we go. Right, that one there, we did one similar to it. That was a U-sub, wasn't it? And it ended up diverging. Okay, here's question 2. How are you going to do the integral x to the power of 6 e to the power of negative x to the 7? What method? I don't need to know the answer, but what method?
U sub.
Agreed. What's the u sub going to be?
Negative n to the power of 7.
Yeah, or x to the power of 7 if you want to use x's. Yes. By the way, that I believe that will converge. Skip by these two because don't want to do them yet. No, don't want to do that yet. Right, want to do this one. Do you notice that these questions now only have 2 choices, convergent or divergent? Will you please not pick one, and if it's wrong, you just pick the other because you get 3 guesses? I mean, that will make your homework go really quickly, but you won't learn much. And if you get a question in the test, what you're giving yourself a 50-50 chance of being right. And if I don't see the working, I'm giving you a big fat 0 anyway. So it's not a good habit. But let's look at, I'll do a version of him. Any ideas how we're going to tackle question 6? Nothing comes to mind?
Integrate it.
And partial fractions?
What? We are going to integrate it. Do you know if that n squared plus 81 was n squared minus 81? I would have agreed with you. That would have been a partial fraction. But because it's n squared plus 81, you can't factor it in, so partial fractions won't work. And someone did say you integrate it, and you're right, we are going to integrate it. But all integral tests involve that. And this fella here is the key to the problem. I need to know how you integrate that. It's not a u sub. If the top line had said 2x or x or 5x, it would have been a u sub. I can't think of a situation where that could ever be an integration by parts. This one ends up being, even although it doesn't look like it, this one ends up being, oh, I have a good memory and I know what certain things, integrals, stroke antiderivatives are. I know what the antiderivative of 2 over x squared plus 81 is. Let me show you. Oops. I would hope everybody knows that one, because that one's a pretty standard one. Agreed? That one is him. What you might not know, and so I'm going to tell you, so you'll remember for the next time, is that if the number here is not 1, if it's 9 or 25 or 100, right? In this case, it's 81. You will get 1/9 inverse tan of x over 9. And so you can just kind of add that to your vocabulary of things I know the integral of. Try another one. If it had been, because these questions are going to change the number on you, if it had been that one, 1 over x squared plus 4, what would you get?
Half inverse tan x over 2.
Great. Are you all seeing how the 81 generates these 2 9s and the 4 generates these 2 2s? Now, what's going to happen then if the top was 11? Well, you're just going to have 11 9s. Do you notice the 11 only goes there? And suppose it was 9 of these, they're going to get a 9 there. And we had, what, 2 in our question? Well, I guess I should do it again. We had 2 in our example. Then won't that be 2 9ths, the inverse tan of x over 9? So 2 9ths inverse tan of x over 9 evaluated at x equals 1 and finishes at x equals t. So will you, I don't know how you say this, but will you try and add that to your little mental box of where you put integrals that you memorize? You know, the kind of thing, what's the integral of e to the x? Oh, it's e to the x. How do you know that? Because I've memorized it, right? I've remembered it. So try and remember the family of 1 over x squared plus something. If you want to know what it looks like in general, it's that guy, right? Well, that was just a small hiccup. Now we have a major hiccup. And you might think, I don't see any major hiccup coming. Well, watch. 2/9, the inverse tan of t over 9. Take away 2/9, the inverse tan of 1/9. And the hiccup is, we have to find out what this is equal to when t goes to infinity. And I don't have very many strategies or methods. Brute force, turn the t into infinity, see what you get. L'Hopital, divide top and bottom by n squared, right? And that's pretty much it. There's not that many methods out there. This is going to be brute force. Now, you might just assume, unfortunately you'd be wrong, that the inverse tan of infinity is just infinite, in which case this diverges. It is not infinite. The inverse tan of infinity is in fact an angle, right? There is an angle whose tangent is plus infinity. At least there is a limit towards that angle where that's true. Can anybody remember what the inverse tan of infinity is?
Pi over 2.
That's the darn guy. And this simplifies down to pi over 9, take away 2/9, inverse tan of 1 over 9. Since this is a number, it converges. Which means that this fella here converges. So after all that hard work, all you do is check a box that says converges. But that's how I know that it converges, right? This is the technique that we've used. And that is not simple. Imagine I gave you, I'm not promising I'll do this, I will give you a question in your test, on integral test, that's pretty much certain. But imagine I gave you this one. In WebAssign, it's just going to have a circle converges and another circle diverges. And you have to pick the right one. In this case, you would fill in that one, and that would be your answer. And as far as WebAssign's homework is concerned, I wouldn't know that you didn't guess. But in a test, if you did that, and I go looking for the working for question 6, but there is no working for question 6, what am I going to assume you did?
Make an educated
Guess.
guess.
Well, or even an inspired guess, or just a guess. None of those are any good. So even if WebAssign gives you 10 points or 15 points, I will not. In other words, I will remove those 15 points. You do not get 15 points because you're lucky. Now, on the other hand, can you imagine doing most of this working, but you screwed up? And because you screwed up, you thought the answer was diverge. WebAssign will give you 0 points. I, on the other hand, will notice that you were doing most of it correct, and so you will get most of the points as partial credit. So there's a plus side, isn't there, to showing you're working? And so one last time and then I won't bug you anymore. Do not do this section by, I'm guessing convergence, oh, it's wrong. I'll guess divergence, now it's right. Took me 20 seconds, next question. Sure, you could probably do your homework in 5 minutes, but I doubt very much if you'd get anything right in your test or the final exam, which I'm probably going to do one of them in there as well. I think that seems reasonable. Since we are in mathematics, we're not in how good can I guess.
aka the SAT score.
Okay, they don't like, well, I guess it could, you can guess in SAT, can you?
Just go to B. Just
I think
circle
if
B.
you guessed, just circle B. I guess if you guessed in your SAT test, wouldn't you get a really bad score?
Not if you're lucky.
Okay, not if you're lucky. Most people are not, so. Okay, here's the next fella. N equals 1 to infinity, 1 over n log n. Now, I'm not going to do the entire question this time. This is basically question 7. I just want to set it up. What method should we use? And this one is sneaky. I'm giving you a heads up here. This is sneaky.
Can we use
What?
them?
Yes, yes. Now the second part of the puzzle is, who's the use up?
ln of x?
You nailed it. Which means, trust me, that'll eventually diverge. And that's 7 kind of looked at. We've done something like 8, so I'm not going to do that one. Oh, this is one I think I will do a little bit different. Okay, well, we know how this is going to start, so I'm just going to quickly write this bit down because all the questions look like this. Oops. There we go. How on earth am I going to integrate 1 over the square root of t plus 2? How am I going to do that, guy?
Could you do it as
Wouldn't that be x plus 2, not t plus 2?
Oops, sorry. You're right. How are we going to do the 1 over square root of x plus 2? You were about to say something and then interrupted. You're
it's
okay.
okay. Would it be like x plus 2 to negative 1/2?
Yes, it would be. And technically speaking, well, my half looks funny, but technically speaking, this is just a power rule. And it's a power rule with x plus 2, which I call the linear shortcut method. So what that turns into is add 1 to the power and then divide by the new power and evaluate that at x equals 1 to x equals d. And then do some style points on it. And then ... Wouldn't it be relatively easy to finish that question off now? So do you see in the integral test there is u subs, integration by parts, weird things like 1 over x squared plus 81, fractional powers, power rule, I think that's everything really. Pretty much everything that could have happened from Calc 2, with the exception of the trig subs, you know, the x equals sine theta stuff. They don't typically harm, so I don't think I'm going to see one of them in the homework. But apart from them, didn't every other technique pop out somewhere in one of these questions? And at the end of the answer is, if that's infinity, diverges. If that's a number, 42, converges. Right, so you get two circles, one is converge, one is diverge. You pick the right one and you are good to go. Any questions about that? Are we getting a feel for how these questions are kind of, how they're working, how they kind of happen? Moving on. Okay, I'm going to go back to the homework only so that we can talk about techniques that we're going to use. Right, look at question 11. What integration technique are you going to do for that one?
U sub.
Who's the use? Correct. Who's the use up?
N to the 5 plus 2.
Right. Could you describe how you came up with that? That's the right answer. How you figured out that was a use up and not something else?
When you take the derivative of the bottom fraction, it'll cancel with the top.
Right. Sounds good. Right. Someone else. Look at 12. Ooh, that's sneaky.
Would it be a U substitution?
It would be sneaky use up, but yes, it's a use up. What is the sneaky use up going to be in question 12?
1 over n to the 7.
What? Yeah. Or 1 over x to the 7 when you get to it, but I know exactly what you mean. Nailed it. I believe that one converges, but don't bet money on it. The last one of this question is easy. It just looks horrible. N to the power of negative 1.1 and then n to the power of negative 1.6. That is in fact the power rule. Yeah. You're used to 9x cubed and 4x squared, right? Power rules are easy when the powers are whole numbers, but doesn't the power rule work when it's x to the 1.7 or x to the negative 1.7, right? It's still add 1 to the power and then divide by that new power. You're just going to have some weird, wonderful decimals floating about. And you might want to think about rewriting your answer. Don't leave it as n to the negative 0.6 because that's hard to tell what's going on there. You might want to change it into 1 over the thing so that when it can, I believe it converges. So I think we've covered enough of, if I give you a series, can you tell if it converges or not using the integral test, right? Now, hopefully you'll get plenty of practice in getting up to speed on it. And we're not finished. We are going to, it's still in the same section, we're going to look at a thing called the P-series. Now, a P-series is a very interesting series. This is a P-series. It's sigma 1 over n to the power of p. So to give you an example of, it's a whole family of series. This fella is called a P-series. P equals 3. This guy is a P-series. P equals, anybody tell me what the P for that
1/2.
P-series is? 1/2. Now, P-series, the kind of basic P-series sticks a 1 at the top, but if there's a 10 over t cubed, or a 10 over n cubed, or a 42 over the square root of n, it still counts as a p series, isn't it? Just a multiple of it. So there's a whole bunch of series that all belong to the family of p series, right? And now I'm going to tell you what is called the p series test. And what it says is, if you have a p series, so it's pretty obvious that the p series test only works with p series, right? But if you have a p series, n equals 1 to infinity, let's call it 1 over n to the p. If p is greater than 1, the series converges. And if p is less than or equal to 1, the series diverges. So you will not be using the integral test for a p series, but you could. If I said to you, does this series converge? Couldn't you use the integral test on it, right? Find the integral of 1 over x cubed and do it. In fact, didn't we do on Friday, didn't I prove to you that the 1 over n guy diverged? Remember him? So does it not make the harmonic series, right, the 1 over n series, does it not just make it a p series, p equals 1? Right? So the harmonic series is just one member of the bigger family called the p series. So if someone gives you a p series, you can use this test to tell if it converges, which makes these questions very easy, I think. Does that series converge or diverge?
Converge.
And the reason it converges is because p is equal to 2, and that is greater than 1, so it converges by p series test. Now, you can't get much easier than a question like that, can you? Now, suppose that was 10. Any difference? Same answer, same reason. Suppose I wanted to do that test, that p series. What is p?
1/3.
Would you agree that is less than or equal to 1? So conclusion.
It diverges.
Diverges.
Diverges. Now, I haven't done it yet, but let me show you. Suppose they don't start at 1. Suppose they decide to start at 2 or 22 or 10. Do you think that makes any difference to the conclusion about converging or diverging? None at all. Can't you stick a 10 at the top? Could you stick a 3 at the bottom? And wouldn't that have no effect on the answer? Here's something even more interesting, I think. Does this converge or not? Well, watch what I'm about to do. Do you know that the funny little is roughly equivalent to, right? Doesn't mean it's equal to, but it's kind of in the same family. Would you agree that this guy behaves pretty much the same way that that guy would behave? And what do you know about that guy? Well, I know he's p equals 3 and it's greater than 1, so it converges by p series test. Now, it's not a lot of work, but can you imagine that if you were trying to prove to me that you knew it converged, wouldn't that be the working I'd see in your test? I mean, it's not a lot, but it's necessary to prove to me that you just weren't a good guesser. So for something that was a lot of work, right, you know, integrating, you know, you had to do a integration by parts and a U sub and maybe even a L'Hopital and all that. The integral test is very valuable because there are a lot of series in the world that are not P series, right? And so you do need the integral test to deal with those. But on the other hand, aren't there quite a lot of series in the world that are not, that are connected to P series? Try this fella. Who does he behave like? Well, let's not do it in one big go. That's too much work. Can I just maybe leave the n squared on the top? Who does 2n to the 4 plus 5 behave like? Roughly. 2n to the 4 plus 5. What could I replace that by?
N to the 4.
Yeah. Yeah. Or if you want 2n to the 4, but n to the 4 will work fine. And doesn't that make this fella then him? And what do we know about him? He's a P series, right? P equals 2, which is greater than 1. So this one converges by the P series test. Isn't that quite a powerful technique for finding out whether polynomials over polynomials converge or not? Because can't you basically just take them and break them down into a P series that they will behave similar to? And then the test for a P series is just if that power is bigger than 1, converges. And if that power is less than or equal to 1, it diverges. Any questions about that? Does that seem pretty good? Let's show you some of the sneaky things that they do. And the question is, does that series converge? Oh, just looked at Timnisov to be my last question. Does that series converge? Well, what you got to do first is, don't you have to convert that into a formula? Right. So, sigma n equals 1 to infinity. If 1 gets you this, and 2 gets you this, and 3 gets you this, and 4 gets you this, what would n get you? Well, definitely a 1 on the top. And what would the bottom look like?
N squared.
So isn't that this guy? Ah, easy now. P equals 2, greater than 1. So it converges
How do you get the 1/10?
by the P. How do I get the 1 what?
The
It's just
1/10?
16.
That's 16th. I just wrote badly. So it's 1/16. It's not 1/10. We cool about that, guy? Now, actually, I know I'm pushing my luck and I apologize for that, but I figure out if I can get this done, we can call this section finished and it would be nice. I need a formula for this. There's a homework question not unlike this one. That's why I want to get this one out of the way. Don't think P series. Think something totally different this time. What gets you 1, 3, 5, 7? What would then get you?
2n minus 1.
Now, that guy is not directly a P series. Agreed? But doesn't he behave like a P series? So it diverges. We learned some cool stuff today. Will you make sure you say hi? And I will hang about for 5 minutes at the end for those people who have some questions.
Thank you.
Bye-bye.
Thank you.
You're welcome.
Thank you.
Kathy, did we learn some cool stuff today? Oh, she's gone. I'll ask you, Dwight, did we learn something? Every time I say it, you go away. Douglas, stay. Did we learn some cool stuff
Yes,
today?
we did.
Now you can go.
Well, I do have a quick question.
Unless you have a
Okay, yeah.
question. Ripken, do you have a question as well? Oh, gone. Okay, I got 2 people that have
Okay, so
questions,
just
that's fine.
I'm a little
Right.
confused, or
Mhm.
I'm trying to visualize how so when P is greater than 1,
Uh-huh.
then that means that it and
Converges.
because it converges, because if it's greater than 1, then it's decreasing because it's a
And it's
higher. bigger
yeah,
fraction.
it's decreasing really quickly is the key.
Yeah. Okay.
And if you decrease quickly enough, you'll converge.
Converge, yeah.
Even 1 over square root of n decreases, but it decreases so slowly that the whole thing adds up to infinity. So it's
Okay.
not just decreasing, but decreasing quickly is the key to success if you want to converge.
Okay, gotcha. And then my other question was, so you know how we did there was like a substitution where it was like, if it was 1 over x squared plus 1, then it could be a tangent, inverse tangent.
Inverse tangent, yes.
Could we just use like the P series and just say it's roughly equal to 1 over x squared?
Right, and that would work. The only issue is that some of the questions ask you to integrate things and do the integration test.
Okay. Gotcha.
So it's not that that wouldn't be a valid solution if the question was just open-ended. Like, here's a guy, does he converge? You can pick, I think right now are we up to about 4 tests? Let's see. We've got the divergence test, the geometric series test, P series test, and the integral test. Right, we're up to 4 tests right now, aren't we? And
Yeah,
there's
I
about
believe so.
9 when we're finished. So
Okay.
it depends on what the question phrases. If the question says use the integral test, or as some of the earlier questions do, they actually say find this integral from 1 to infinity, then you're kind of locked into that technique. But if it doesn't, and you can do it with the integral test, or you could do it with a P series test, whatever one makes sense to you would be totally valid.
Okay, cool. Thank you.
Is that us? Yeah. Okay, Sam, what you got?
I do have one question.
Yes.
Cool. So this is question 17 of the second section, but it's sigma of tangent inverse of 4n.
What comes after the tangent inverse?
Inside is 4n.
4n. Gotcha. That's all I need. So I'll skip over to the white screen now, and I'll show you how I would approach that question. Right. So this is going to be a divergence test. So I am just going to find the limit as n tends to infinity of this fella. Now, according to the divergence test, if this is equal to a number or infinity, the series diverges. So in this case, I'm going to do a brute force. Isn't 4 infinities infinity? What is the value of the inverse tan of infinity? It is a number, isn't it? We did it today.
Pi
Can
over
you
2,
remember what
right.
that? Pi over 2. And by the divergence test, then the series diverges.
Okay, so when I did the homework, it didn't like the pi over 2, and it said that it
Well, it
wasn't
wouldn't
right
like
and
the
that
pi
it,
over 2 because the answer will be it diverges, so it'll be DNE.
it has a multiple choice, so convergent or divergent, and then it has
Right, so
the
you pick.
and.
Right, so what
And-
your answer would be it might have a dot where you pick and then a box that comes later, right?
Mhm.
A box like that, right? Then when a series is divergent, you choose that one, and the box does not get that guy.
I think I see what it's
When it does not exist, that tells me that this actually adds up to infinity, or at least it adds up to a non-finite number.
Wait, so why does it diverge? I mixed up divergence and convergence
Right.
for a second.
Diverge means that the answer is infinitely big, or the answer doesn't exist, right? DNE.
I think
So
I see his
if the
problem.
individual, right, see if these end up homing in on pi upon 2. If you add up a whole load of terms and each one of them adds up to pi over 2, won't you end up with an infinite total?
Okay.
So
That makes
this is a number, but each of these can't be a number because an infinite amount of numbers added up gives you an infinite sum, right?
Mhm.
The divergence test catches those series where the individual terms do converge to any number that's not 0, means that it's a divergent. And so the box, you don't put in pi upon 2 in this box, you put DNE, because they're asking what does this equal, not what does that equal.
Okay, that makes sense now.